Pleasure to introduce Jacob Andreas. Jacob's an associate professor at MIT in the Electrical Engineering and Computer Science Department, also a member of the Computer Science and Artificial Intelligence Laboratory. As I understand it, Jacob interested in language as a communicative and computational tool, and the research of your group aims to understand the foundations of language learning and to build general purpose intelligent systems and communicate effectively from human guidance. Considering the widespread public use of large language models these days, cannot imagine a better speaker as we sort of collectively struggle through even the sort of basic questions of, what does a large language model understand? Do large language models have a model of the world? What does it even mean to ask that question? So we're going to talk about belief, uncertainty, and truth in large language models. Jacob's going to talk for about 30 minutes or so. Then we'll have about a 15-minute chat, and then we'll spend about 15 minutes for any questions from the audience. Great.
Yeah, thank you so much for the invitation. So to start off with a little example here, if we take the Now it's on. This is remarkable for a couple of different reasons. The first is that it is correct, right? We have now sort of automated systems that can answer open-ended questions about things from history to physics to mathematics to sort of mid-century South Indian politics, all just in a sort of totally automated fashion without consulting the internet or anything else. The second thing that's kind of remarkable about this is that it not only gave this answer, but it followed all of the instructions that we provided. Its output numerical estimate of its confidence as a number between 0 and 100%. And this is, like somewhat complicated instruction and not what most of the question answering data in this model's training data look like. Things get a little bit more complicated if we take this question and we make just some small changes to it. We ask now, was Chalapanian first appointed in 1937? Again, give an answer and a numerical estimate of your confidence. In this case, the same model says yes to the same question, and it is even more confident that the answer was 1937 rather than 1962. And obviously, it is not possible that that the answer to both of these questions is yes, and in the second case, it happens to be wrong. Now, I want to claim that two different things have gone wrong here. The first is the obvious factual error, right? We asked a factual question and the model gave us an answer to that question that was incorrect. And the second is an error in some sense of metacognition, right? That we asked this model to answer two closely related questions, and the answers that we got to these two closely related questions were not only contradictory with each other, but the model assigns high confidence to two things that cannot possibly both be true. So in the first case, it was overconfident because it would say yes to contradictory things in other contexts. In the second case, it was also overconfident because it assigned high probability to this, and the answer was actually wrong. And so one way to think about what's going on here kind of systematically is that in the first case, the language model has a poor model of the world and the kinds of things that are true in the world and the kinds of facts that can be true at the same time in the world as it exists today. And what's gone wrong in the second case is that the model has a poor model in some sense of itself. It doesn't know what kinds of questions it's likely to get right, what kinds of questions it's likely to get wrong. In some sense, it doesn't know what it knows, even when we ask it to report that information correctly. So we're going to sort of work up through this talk towards maybe technical solutions that we can start to build towards addressing these questions. Before we do that, I want to start by really talking at a relatively high level about how it is that we even go about constructing language models in the modern era in the first place, and why it is that the current training pipeline both gives us these really impressive successes, but also failure modes of the kind that we were looking at just now. So, right, I think at this point, most people who have read some amount of popular literature about language models have a picture of them as something like this in their heads. language model is some kind of big neural network in the modern era that takes in a sequence of words as input and tries to guess what word is going to come next as output, right? So this is just like the thing that was on your, cell phone back when predictive text was new on cell phones and trying to guess the word that was going to come next. And the only difference is that we've trained it not on, sort of a little dictionary or a little collection of texts, but on, to a first approximation, the entire digitized corpus of everything the human species has produced since the beginning of history. So this is a sort of high-level picture of what a language model does, right? It predicts the next token in a sentence. What it doesn't tell us is how we actually got there. And actually, I guess before talking about that, the sort of thing to note is that once we have a machine that's really good at looking at an input and just predicting what token is going to come next, if we can do this super reliably, we can start to do all kinds of other things, right? We can start to do controllable open-ended text generation by feeding as input to the model something like the title of a newspaper article, the subtitle of a newspaper article, the word article : and asking what's going to come next. And if you imagine a really good predictive text system, if you imagine that you came across this text in the wild somewhere and you were asked to guess what was going to come next, you might guess that what was going to come next was the first word of an article. And so we go to our language model, we say, just tell me what's going to happen next, and it says, well, after is the most likely word to come here, and then we can just repeat this process over and over again to go from a sort of single next word predictor to a generator of entire coherent news sources. And again, this is an older model, so maybe less surprising. It turns out that this very plausible, very well-written little paragraph summary of a schism in the Methodist Church is also like made up and introduces a bunch of details that never happened. Maybe more surprisingly, another thing that we can do with these kinds of models, once we get them into their final state, is to follow more complicated kinds of instructions, right? So if you have interacted with something like ChatGPT or any other kind of language model out there, probably most of the interactions that you've had with it are of the following kind. You give it an instruction like explain the moon landing to a 6-year-old, and what pops out of the model is some text that explains the moon landing in language appropriate for a 6-year-old, or you ask it an open-ended question like why do birds migrate south for the winter, and what pops out of the model is an answer to that question. And so, maybe the sort of question that should be in your head at this point is, what is it that we actually had to do to construct that neural network that generates these particular next token predictions that make these models useful for all of the kinds of tasks that we were looking at before? And often the way this is sort of described at a high level is you just learn to predict the next token in a bunch of text that you got from the internet. The reality is that it's a little bit more complicated than that, and there's a sort of 3 or 4 stage process that we use for building modern models. And I think understanding the dynamics of this process are actually pretty important for having a good mental model of the kinds of things that we should expect language models to do or not to do. So the first piece of this process really is just as we described. We go out, we get as much text data as we can get our hands on. Text doesn't just mean language, it also means code. It means tabular data. It means like really any sort of structured thing that you can encode as text. Nowadays, often representations of images and other kinds of things are often thrown in as well. And we do just train this model to be a really good next token predictor, right? So we have the weights of our neural network. We show it a sequence of words as input. The neural network guesses what word or sort of set of words are plausible to come next as output. And if it's wrong, we wiggle its weights a little bit so that its predictions are slightly more likely to be correct the next time around. But what happens if we just do this and we try to use a language model trained in this way, right? A language model designed to do a good job of predicting the next token that's going to show up, the next word that's going to show up in random web text. Well, if we think about even the examples that we were looking at before, right? Explain the moon landing to a 6-year-old in a few sentences. The kinds of outputs that we get, and these are from a smallish LM, but real examples from something that you've just pre-trained, look like this. We say, explain the moon landing to a 6-year-old in a few sentences, and what the model predicts is likely to come next after that is make a fun fact about the moon landing for kids, explain how the astronauts really did make it to the moon. Right? It is just as plausible if I were to hand you a random website on the internet and say what's going to come next after explain the moon landing to a 6-year-old, that this website contains a list of fun questions to ask your you know, I don't know, your co-parent for teaching your kid about the moon landing, as it is to actually contain answers to these questions. And so something that's just a sort of general purpose statistical text prediction system is not necessarily going to follow instructions when you issue instructions to it. It might equally well guess that you're asking it to fill out a list of instructions, and it just wants you to generate the next instruction in that list. Similarly, when we think about why do birds migrate south for the winter, sometimes you get answers that are just not useful or that seem like sort of weird answers to jokes or things like that. And so if we want to make this model useful, we want it to be not just a model of web text in general or of text in general, but somehow a model that actually sort of adopts a consistent personality that responds to instructions rather than behaving in some other way when prompted to do so. And that, when you ask it questions, actually gives like useful, reliable answers to that questions. So just to say this again, just doing sort of pre-training, like we said before, on large-scale text lets us generate sort of plausible, fluent completions, but for the most part, not useful outputs. And so the next thing that we'll often do in order to construct one of these models is something called fine-tuning. And what we do in a typical fine-tuning process is we actually get now a pair of humans to role play a conversation between a human and whatever AI system we're trying to produce at the end of the day. So we have one human acting as the user who says, can you help me rewrite a sentence using simpler words? And then we have another human user role playing as the language model that we're eventually trying to produce that says, sure, what's the sentence? And we generate conversations in this way between people and bots. And we collect a bunch of data of this kind. And often, because we have to sort of pay expert people to do this, we have to train them in the kinds of conversations that we want to generate and so on. We have much, much less of this fine-tuning data than we had at that pre-training stage that we talked about before, but we have a little of it. And what we're going to do now is we're going to take that model that we started out with, and we're going to continue to ask it to play this sort of next word prediction game, but only on these conversations between our humans that are meant to simulate conversations between humans and a bot. And so what's going to happen when we do this is that this model is going to retain whatever sort of knowledge about the world that it needed to acquire during that pre-training phase in order to be a good general purpose next token predictor. But now we're teaching it specifically the kinds of responses that you ought to give should be the kinds of responses that people produce in the sorts of interactions that we're using to train this model. And so this is going to get us a little bit closer to what we wanted in terms of the kinds of answers that we want, but things can still go wrong. And in particular, right, if we go to our sort of explain the moon landing to a 6-year-old, this is not a real example, this is now fake, but representative of a category of things that can happen here is that we can get this model, and the model will generate a response to the particular question that we asked, but it's a response that happens not to be factually true. Now, why is this? Well, we pre-trained this model, right, on the internet and on a bunch of other text. The internet is a scary place. It's full of things that are not true. It's full of things that used to be true but are not true anymore. It's full of sort of weird beliefs written down by people who have a lot of time to write them down and generate a lot of text. And all the model has learned to do is to learn the entire distribution over things that people on the internet say, right? So if it's the case that, sort of in 90% of conversations about the moon landing that happen on the internet, people say, yeah, we landed on the moon, NASA did it, it was a real thing. And in 10% of those conversations, people are saying the moon landing was a hoax. Then what this model has to learn to do during that pre-training phase is 90% of the time output a sentence that says the moon landing was real, and 10% of the time output a sentence that says the moon landing was fake. And that is the behavior that actually sort of is going to make this training procedure, or the training procedure is going to push it towards. And so when we then do this fine-tuning phase, unless we have specifically fine-tuned on data about the moon landing, we haven't necessarily communicated to this language model which set of facts about the moon landing it ought to believe, which set of facts it should sort of produce in contexts like this. And notably, right, maybe not here, but for lots of other things, especially having to do with kind of popular conspiracy theories and urban legends and so forth, the majority answer that shows up on the internet to, is Bigfoot real or whatever, is going to be text talking about the reality of Bigfoot. And so these are the kinds of things that models are going to find overwhelmingly probable, even after we've sort of fine-tuned them to generate responses in the right format. And so as a result of this second phase, right, this fine-tuning phase, we've produced models that are not just models of web text, but actually models of conversations, but nevertheless not necessarily models that know the facts that we want them to know, or that sort of exhibit the particular behaviors that we want them to exhibit. So to summarize here, right, the combination of this pre-training and fine-tuning phase give us language models, next, sort of text generation systems that talk like chatbots, but that don't always specify but this procedure doesn't always specify how these systems ought to behave in all of the situations where they find themselves. And so a last thing that is typically done is to train these models now not on simulated conversations between people and the systems themselves, but to instead get feedback on the system outputs themselves, right? So now we get some user of the model to say, can you write a fake doctor's note to get me out of school? And we ask the language model, we prompt the language model to generate two different possible continuations of this response. One where it says, here's the fake doctor's note, and one where it says, sorry, I'm forbidden from writing fake doctor's notes. And then we ask either people or some other sort of automated judging system to go in and look at all of these responses, pick which one is more likely to be true and which one is more like the kind of response that we want and which one is less like the kind of response that we want. And again, tweak the weights of the model so that it makes the second response more likely and the first response less likely to pop out the next time we query it. And so this helps us a little bit, right, in the sense that this is now a way, especially if you're doing this automatically and especially if you're doing this at a very large scale and you have some other, sort of people doing fact checking of model outputs or automated processes that can do fact checking of model outputs, that can sort of actually steer the model towards stuff that is factually true, right? So if we go and we ask our explain the moon landing question again after this third phase, sort of typical model response is something like people went to the moon and they took pictures of what they saw, like we saw before. However, another very common side effect that people observe as a result of this phase, especially if the feedback that you're getting is from real human annotators, is a phenomenon that's sometimes referred to as sycophancy, where models will basically infer, based on whatever interactions you've had so far, what kinds of responses are likely to be judged favorably by the particular annotator or annotation system that you're interacting with right now, and to produce the kinds of responses that that annotator is likely to say yes to. And so in particular, if you're in a context where the annotator has provided information suggesting that they are already inclined to disbelieve the moon landing narrative, then models are actually going to be incentivized to, again, produce the conspiracy theory answer, because they have inferred that the person generating the annotations for them is a conspiracy theorist and is going to upvote the conspiracy theory answer. And so even this final phase of actually judging model outputs, which is sometimes called reinforcement learning with human feedback or reinforcement learning with AI feedback, can produce models that now give factual answers when they know they're going to be graded on producing factual answers, but that give incorrect answers when they know they're going to be graded by somebody who's expecting an incorrect answer. So saying this again, learning from human feedback or from automated systems that were constructed by humans or derived from human feedback give us finer grained control over how models are going to behave. But what they don't do, at least the way this is practiced right now, is ensure consistency across interactions, is ensure that what we're going to wind up with is a model that always answers the same question the same way, or that adopts a sort of consistent persona that follows a consistent set of rules from exchange to exchange. A final thing that we do sometimes now, instead of these last two phases, is to cut the humans out of the loop altogether and say, let's just fine-tune this model on tasks where we can write some sort of automated answer judging system that doesn't, where we sort of have access to ground truth answers and don't have people in the loop at all. This is easiest in both sort of simple factual question answering tasks where there's like a single well-defined answer, and in things like math and programming problems where you can just, evaluate a numerical answer or run some tests or whatever. So this is often referred to instead as reinforcement learning with verifiable rewards rather than with human feedback, and we can do it for these kinds of things. What's especially useful about this is that it's a way of training models to actually generate sort of natural language reasoning traces that eventually produce the right answer, even without getting people to sort of manually write those reasoning traces themselves. However, as we saw before, one sort of failure mode of this, especially if our judge here is just looking at these models' outputs, giving it a thumbs up for producing the right answer and a thumbs down for producing any other answer, is that there's no incentive to hedge. no incentive to really express any kind of uncertainty here at all, because this automated judging system is only ever going to give you points for getting the right answer. And so you might as well guess whenever you're uncertain, because that's certainly better than saying, I don't know. So yeah, I guess on this last point here, learning from automated feedback in this way is useful for making models that are better on those tasks that have really well-defined answers or sort of, automatically constructible feedback signals. But the way we do this, right now, doesn't disincentivize guessing or incentivize consistency in exactly the same way that we saw with human feedback. Okay, so to sort of summarize the state of things right now. With the suite of training recipes that we've just talked about, we wind up with models that sort of interact with people in useful and human-friendly ways. We have training methods that increase the probability that models are going to produce truthful outputs, at least when they know they're being graded on truthfulness, and decrease the probability that they produce responses that humans are going to judge to be harmful. But what we don't get from the current training recipe is either the ability to force these models to really be consistent, to adopt the same personality, to give the same kinds of answers across contexts, or to sort of possess metacognition in the way that we were talking about at the beginning of the talk, to do things like say, I don't know, and build some sort of internal representation of what they know and what they don't know. So what is the mental picture that we should have of these models to cause all of this stuff to be true? I should ask, how are we doing on time? 10 minutes? Okay, cool. I think we can get to the end in 10 minutes. Good, right.
Do you mind using one of these, and I'll see if I can get you another one. Thank you.
Does that work? Yes. Good. So one way this question comes up a lot in the context of modern AI systems is whether they possess internal world models, right? Should I think of, and this is often offered up in contrast to thinking of language models as stochastic parrots, right? Should the model that I have of this system be as some sort of babbling statistical text generation system that really doesn't in any internal way represent anything about the world, or should I instead think of them as having, in some sense, a coherent model of the world and of what's true and false in the world that they are consulting when answering questions? And I think we could spend a lot of time, certainly more than the next 10 minutes, talking about what it means to be a world model or to possess a world model or a model more generally. But I think if you look at the kinds of objects that through the course of human history we've been inclined to describe as models or to use as models, one of the things that really pops out is that accuracy is often not the sort of most important feature that these models have. It's instead some notion of coherence or internal self-consistency, right? What distinguishes or what makes useful, something like a model of the solar system is the fact that I can answer it, or I can ask of it a bunch of different questions about, say, the motion of the planets or the relative position of planets or things like that, and expect all of those answers to agree with each other, even if this model is not able to answer every question that I have about the solar system or to answer all of those to a very, very high degree of accuracy. And really, again, sort of throughout the history of the sciences, it's trying to build models that are internally coherent, maybe more than precisely explaining all of the data that we have today, that has given us the kinds of theories that have in turn allowed us to make accurate predictions. And so what would it mean for a language model to have a world model in this sense? Well, maybe something like understanding not just what facts to produce in response to particular questions, but to understand or at least represent in some way relations between facts and the procedures that you need to derive conclusions from new facts, and so on and so forth. And so if we wanted to talk about language models having having internal world models or having beliefs or having knowledge, probably a first condition that we would want to look for is coherence in this particular sense. And I don't want to sort of overstate the failure modes that we were looking at in the sort of first portion of this talk, right? Certainly it is the case that for most of the questions that you're going to ask one of these models on a day-to-day basis that aren't like really designed to test these sort of obscure bits of trivia, the answers that they are going to give are going to be internally consistent with each other and are going to appear, at least to you as the user, or it's going to appear to you as the user that the model is the same model that you're talking to every time, even if those interactions look very different when other people are talking to it. But if we really want to sort of push this all the way to the end, right, and if we really think that having internal models of the world or internal models of the self is going to be important for building systems that are more reliable or more usable or at least more predictable to the human users, then probably we want some way of optimizing for internal coherence in this particular sense. And again, this is not something that we get from the kinds of training recipes that we have right now, but is something that we could imagine baking into those recipes in the future. And so to sort of wrap up here, I want to give just a couple of vignettes of what this might look like and the kinds of things that we can do to train these models differently if what we care about is optimizing not just for accuracy at next token prediction or accuracy on math problems, but these more sort of meta-level properties like coherence. One is to optimize for external agreement between all of the facts that the model is willing to say yes to, and a very simple thing that we can do here is just pick up a language model that we've trained in the way that we described before, ask it to write down everything that it knows about some domain of knowledge, say the Japanese emperor. Oh, something's going wrong with the animation here. And once it's written all of those things down, to look at all of them and identify which of those statements contradict each other, which of those statements entail each other, and what it thinks sort of marginally the probability of each of those statements is to be. And once we have all of these judgments from the model, right, about what things are logically consistent and which are not, we can just automatically pick out the subset that both sort of is internally in agreement and is most likely to be true on the margin, and then just train the same model on its own outputs to sort of decrease the probability of things that were judged upon reflection to disagree with everything else that the model knows, and upweight those things that were judged upon reflection to be supported by the other available evidence. And this was work done by Faiza Akurek, who's a grad student who collaborated with us at BU. And the sort of surprising thing is that when you do this, right, when you optimize not for accuracy, but just for internal coherence in this way, and then you evaluate models on their ability to give accurate responses on fact-checking tasks, accuracy does go up. So we can think of this in some sense as confirming that hypothesis that we had before, that optimizing for coherence, even when we don't have access to all the ground truth answers ourselves, is a way to just make models more reliable. And maybe more interestingly here, we can also look at the set of situations in which the model actually contradicts itself. The bottom 3 rows here are just different versions of the same procedure. And the main thing to notice is that if we sort of curate a data set of very closely related statements that can't both be true, optimizing coherence in this way decreases the rate at which models make mistakes of exactly the kind that we started the talk with. So what about self-knowledge, right? What about sort of training models to know what they know and what they don't know? Well, if we think back to what went wrong at the very beginning here, we can think of this basically as a problem of the model being too confident, right? It said yes to this question, even though there were other situations in which it was also likely to say yes to contradictory questions. And the thing that we described before as reinforcement learning with verifiable rewards basically says we're only going to give the model credit, and don't worry about all the notation here, but for producing the right answer. What we can do instead is just during the training procedure, always train the model to also generate these sort of verbalized estimates of its own confidence to say, I think the answer is yes, and I'm 80% accurate, and reward the model when it says yes, and it's right, and it produces high confidence for those answers, to penalize the model for responses where it says yes and it's right, but it output low confidence in its answers, and to actually reward the model more than we might have done otherwise for situations where it's wrong, or say where it says yes, it's wrong, and it assigns low confidence to the answers that it produced. This is an application of a very old idea from decision theory, but it turns out it has some really nice theoretical properties, and that you can actually sort of prove in the limit that this will cause models to truthfully self-report their own internal confidences. Not going to talk too much about the details in the interest of time. The main thing that I want to say here, though, is that this is not absolutely a panacea. The thing that we're looking at in blue here is the sort of standard training procedure that we talked about before. The thing in pink is this improved version on the right that's designed to improve the calibration of models, their sort of self-knowledge. And what we're looking at here is the sort of total probability that the model assigns to all of the different answers it can generate for a given question. And we can see, you know, what you would expect, right, in a model that was sort of totally well calibrated, that knew when it was going to say yes and knew what it didn't know, was that none of these would be greater than 1, right? That if the model says 80% confident in one answer, we cannot find any other set of answers such that those confidences sum up to more than 20%. Nevertheless, even after applying this fancy training procedure, we can find individual questions where there are sort of 15 distinct answers that the model is all willing to say, I'm 100% confident that this is the right answer. So still very much a problem to be solved. And I think to sort of wrap things up here and set up the discussion going forward, we can talk about technological solutions to these problems of accuracy and coherence and self-knowledge and things like that. But at the end of the day, we can only sort of design these objectives if we know what it is that we actually want to optimize models for. And I think there's a huge amount of work to be done, especially in the policy space and in a way that's relevant to this crowd, in figuring out just what are the kinds of questions that we ought to be asking about these models in the first place, right? To the extent that we have to trade off between models that are accurate, models that give the same answers to sort of questions whose answers are related to each other, personalization, right? Models that can sort of specialize themselves for individual users or behave exactly the same for all users. Predictability, models that are legible to users, models where users can figure out before asking a question whether a model is likely to get the answer to that question right or wrong. All of these things are in competition with each other. We probably can't get all of them at the same time. And we need some framework for figuring out how to trade these things off when we're actually deciding to construct a model. Once we then think about the interface with the user, right, we need to communicate to the user when the model is certain and when the model is uncertain. And one way to do this is to say, okay, here's an answer and I'm 20% confident in the answer. But we know from lots and lots and lots of work on data visualization and HCI that people do not understand what 20% accuracy means for the most part. And there are many other things that we do when we're interacting with people to form accurate mental models of the kinds of things that they know or don't know. So should we come up with better language for communicating uncertainty? Should we cause models to just like look dumb or look incompetent when they're giving answers to questions that are unlikely to be correct? Are there other interfaces that we should be building? If you've seen like Martin Wattenberg and Fernanda Villegas's work here on dashboards for models, should we be building things that aren't even language models, but wrappers around them that communicate that uncertainty instead? Oh yeah, and I guess we touched on this personalization point before, but there is some fundamental trade-off, right, between models that can specialize themselves for individual users and offer everyone a sort of personalized, optimized individual experience, but also models that aren't telling users things that they want to hear even when those things aren't true. And again, even figuring out sort of the language for describing this trade-off, I think is a really important question that is not a technical question, but needs to be answered before we can figure out how to optimize for these things. And with that, I will, start to wrap up. So, sort of final notes here. A lot of the problems that we have with models today, you can think of as problems of internal coherence or consistency, and we can start to think about ways of optimizing these models that optimize for those things in addition to accuracy, as we've done sort of historically. At the same time, consistency is not the only sort of meta property that we want models to have. We really care about them being sort of useful and predictable by humans. We care about them being easy to steer, and I think there's a huge amount of sort of conceptual work to be done before we can even figure out how to train models to do these things. And with that, I'll wrap up. All credit, especially in the last half of this talk, to the students who actually did the work, and to all of my other collaborators. Thank you.
Thank you. Thank you for that talk, Jacob. Really appreciate it. Please. So maybe some place to begin with a little more technical questions, then curious to get to a lot more of like how ought the models behave. What struck me listening to your talk, watching your talk, was I had this image, do you know of that Shoggoth meme? Of there's like this horrible looking creature that is sort of representative of internet text broadly, and it's kind of holding up a smiley face, I'm sure you've seen. When you think of optimizing for logical consistency or for calibration, To what degree do you think you're just like putting a smiley face on consistency versus like actually impact whatever it would mean to actually impact some deeper representation that the model has?
Yeah, well, so maybe I think there's two pictures that you can have of what the monster is, right? One is that it's the stochastic parrot picture, right? That there is sort of underlyingly, as a result of all of this web text, no coherent underlying model of the world or of the language model or whatever.
Right.
And if that's the picture, then presumably like baking in objectives that explicitly optimize for these things
Right.
are actually going to sort of shape the sort of deep underlying representation that the model has of the world. Another picture you can have of the monster is that the monster knows exactly what the world looks like, but has also learned that in order to be a really good generator of web text,
Yep.
you need to sort of consult your model of the world, consult your model of a conspiracy theorist, and then generate the kinds of things that the conspiracy theorist is going to say in a world where everything that you know about the world is true. And I think when, maybe even whatever the origin of that meme is like 2020 or something,
Totally.
and I think in 2020 probably the monster was just like massive statistical predictors, and now the monster is probably like a real underlying model of the world. And in some sense, all of these fancy tricks that we've talked about at the end are just ways of communicating to the model, or via the optimization process that we're applying to the model, that what we want is outputs that are consistent, as opposed to any of the other kinds of outputs that you already know how to generate.
Interesting. What struck me about that is, so that transition a bit that you described, do you feel like, is that just a matter of better gradient descent, better data? Like,
Just more data.
and so just with more data, it's just kind of like the internal representations become more faithful.
Yeah.
That kind of thing.
And again, not entirely,
Not
but
on average or something.
and I should say, like with any kind of sweeping statement that you want to make of the form, this is how a model works, it's not true. And another sort of read on the monster picture is that like things are just very messy, and certainly it is both the case, even in very large scale models, that there are domains of knowledge in which stuff is totally disorganized and chaotic, or in which the only model of the world is the conspiracy theorist's model. But at the same time, there are definitely lots of cases where I think you can even sort of look inside models and see how they organize their knowledge of mathematics and find pretty clean representations.
And then is your picture, as you sort of fold on these other objectives that are optimized, that is then shaping these models in some way. So is your picture, there's like other kind of meta principles that we should just be layering on top, like compositionality or transparency to users? Is that the picture? Or
I mean, basically, yeah. So, I think there's a school of thought, right, that says it is not worth trying to do anything fancy other than train a bigger and bigger model on more and more data.
Yeah.
And that in the course of doing that, you will wind up with a model that, whatever, has a sufficiently rich model of the kind of thing that an AI researcher would eventually ask it to become, that all you have to do is ask nicely for the set of behaviors, and that's the model that you'll get out. It doesn't seem like we're getting, if that were the right picture of the world, it would feel like we were getting closer and closer to it as these models get bigger and bigger. And many of these problems actually get worse with scale, right? Something that has been documented with regard to sort of conspiracy theories and so on and so forth. At least there was a period during which that rate actually increased as models got bigger. Certainly something that we've seen as this sort of like reasoning training for mathematics and programming has been introduced to models, is that reasoning training procedures increase the rate at which models make mistakes. So yeah, and then I think the alternative is just saying, well, clearly just optimizing for accuracy is not it. And we need to figure out what the other things to layer on top are.
And then I'm curious how you think about this. What happens for me a bit then is I think about stacking all of these different kind of like meta principles or objectives on, is then they all start interfering maybe in strange ways.
Yeah.
And so like what happens then, or it's just like we'll figure it out?
Well, and I think this comes back to things that are maybe not even questions about how to design the objective function, but just questions of what is it that we actually want. And the Raphael Milliere, I think, who's a philosopher, has a really nice recent paper on, even the sort of standard language that a lot of people use for talking about the the objectives that we're optimizing for in this RLHF phase are helpfulness and harmlessness. And we simply want models to both be helpful and to be harmful, or helpful and harmful, or helpful and harmless and honest. It is very easy to construct scenarios in which those maxims come into conflict with each other. And right now, at least the sort of methods that people are using in the AI community are not specifying what model behavior ought to be in situations where those conflicts arise. To maybe talk about one other sort of category of question that we didn't get to today, but I also think is really important, right? If you have the view, and I think this is a naive view, but maybe right as a first cut, that what we want to produce before we even start training these models is just some like really detailed specification document that says, okay, here are my principles that I want the model to follow. Here are all of the edge cases, and here's how you should navigate trade-offs in all of the edge cases that are going to arise. And you see, like OpenAI publishes their version of this document.
Model spec.
Yeah, exactly. And it's like a long document. It's very carefully thought through. It contains an enormous number of edge cases. It's full of holes. And I think part of the issue here is that, we as people are just not actually smart enough to sit down and write off in one go a fully consistent spec for how a model ought to behave, even if we had already, sort of whatever, we're perfect like moral philosophers and had figured out in a more general sense what it is that models ought to do. So I think there's a huge amount of work to be done, even in like building tools to help with that alignment process, or maybe that specification process, and tools for helping people think about what actually are the edge cases that we're going to encounter, what are the kinds of questions that we haven't considered when we wrote down one of these specifications or when we annotated our data set or whatever.
And is there even a fully consistent, like, can we even write down?
Well, right. And, and even if I can write that down for me, it's not going to look the same for you. And it's not going to, so, and this again is, I think, something where there needs to be a conversation, not at the level of AI labs or individual academic researchers or whatever, but as a society for how do we decide as a society how it is that we want these models to behave?
Yeah, maybe then shifting a little bit then to the user experience, and like you said, these conflicts, but that made me think of something we've been thinking about a little bit here at BKC is, conflicts, sorry, maybe said differently, the way I understand a lot of your work is you're trying, at least in what you showed, to train sort of the inconsistencies out of the model. Another version is just like, hey, the user instructions or system prompts itself might contain inconsistencies, and is there an alternate way, maybe you think about it, where rather than trying to train out the inconsistencies, almost at inference time, can we train a model to resolve the inconsistencies for the user? Or how do you think about something like that?
Yeah, and I mean, certainly we also want to do that, right? So another, I think, pretty striking feature of these models for a very long time was that they didn't ask questions, right? If you issued an instruction that contained some sort of false presupposition or gave an extremely vague instruction or whatever, the sort of first generation of models that we'd have would pick some interpretation and run with that. The second generation, after being RLHF to death, would answer every version of the question all simultaneously in a single output. Yeah. And I think we're just starting to see people train these models to actually, in a way that's sensitive to the context in which interaction is going to take place, and to ask users clarifying questions when it's appropriate. That, again, I think is something where it's pretty hard to get the training data, right? Okay. That, sort of necessarily interactions between this particular model that you've trained right now and a human are not something that any examples of exist on the internet. And so there's sort of nothing that you can do but have live interactions with real people and figure out how to then like judge those in a way that gives you a useful signal. And, I think both as kind of an experimental design question and as a learning problem, that's just very hard and an active area of research.
And it feels like so dependent on the specific user. how they wish to be navigated through that.
Yeah, well, exactly. And and so I think you can say, okay, there are going to be some ambiguities in the model specification or the task specification that will leave unresolved until the last minute and the conversation with the individual user. But certainly there are things that you don't want to do in that way, right? Cases where right, if you're of the perspective that models shouldn't be issuing instructions for how to construct bioweapons, and there's some hole in the spec by which you can construct a scenario where it would be appropriate to.
It's my fictional game.
Yeah, exactly. Probably we don't want to wait until the last minute and ask the user. I'm trying to decide whether to help you synthesize anthrax or not. Would you like me to do it, or would you not like me to do it? And I think that shows up in subtler cases also, right? There's a lot of conversation right now about sort of psychosis induced by interactions with these models directly as a result of these sorts of personalization behaviors. And again, I think when you're inside one of those interactions, of course you're going to say, keep giving me exactly what I'm asking for. And it's only when you sort of think about, when you're able to step outside the interaction, and when you're thinking about this, this person's child or this person's partner or, themselves 6 months in the past or 6 months in the future, that you can say, this is not what we want.
Yes. And maybe before one final question, just to say, if audience wants to start thinking about questions you might want to ask, and then especially, I think, Jacob, you were interested in just like, how ought these models behave? And so if you all get questions simmering about the ought, I feel like that would be especially good.
Yeah. And again, I'll say this is something where, as academics in computer science, there's not nearly enough contact with the policy world. And I think, we can sit here coming up with things that we think might be useful to optimize, but ultimately the decisions about what those things look like need to be informed by, I think, a better understanding, at least, than we in my group have, or I think most people who sit in the same kinds of positions have, of the societal context in which these systems are embedded.
So then, not to ask you and ought, even though we want to study, then what I think of in some of the work is, especially as you're trying to communicate uncertainty to user, that to me itself, it sounds like, is its own user interface question. Like, should it do a bunch of like ums and uhs and like, I don't really know, but like I'm a limited AI model couching, responses, or does it give a number? How do you think about that?
Yeah, well, I think that's an empirical question, and that is something probably where personalization is great, right? And if you're an actuary, certainly you want the model to say, I'm 75% confident in this particular answer. And if you're a 6-year-old, you want the model to say something totally different. And I think, again, that's one of these just like trade-offs where it's difficult to sit down and, write down ex ante, here are all of the things that we want.
Yes, got it.
Yeah.
Interesting. Have many follow-up, but maybe, is anyone from the audience? Please. I think we have a mic.
Thanks a lot for your talk and the discussion. My question is following up on this point of communicating uncertainty to the users. When you first presented the slide of the model's confidence, my first question was like, what does that actually mean? In other words, like, what is that randomness over? And I'm curious if you could speak to that. And then also, if you had to take like a first pass approach at like one sentence that you would type out to the user, like writing out what that uncertainty means. I'm really curious about that.
Yeah. Great. So what is that? What is the interpretation of that 75%? I think is a really interesting question. When you talk about pre-trained models, they are, even though we talk about them as like generating a single next word, they are actually models of a whole probability distribution over next words. And in fact, if you just repeatedly say, continue the sentence, often in pre-trained models for those kinds of factual questions, in at least like carefully constructed contexts, the probability that an answer is emitted by the model is reasonably well correlated with the probability that that answer is correct. At the, when you sort of look in aggregate at sort of all of the answers that the model is producing, right? If I take everything where the probability is approximately 70%, then approximately 70% of things in that bucket are going to be right. When you do any kind of reinforcement learning, that behavior goes away. And in some sense, all we're trying to do in this last phase is get that back and to ask in that sort of external sense that when the model says there's a 70% chance that this is right, that about 70% of the time it's going to be right. There's another interpretation that you could also assign to that I think is closer to what people often think about when we talk about our confidence in our answer, which is just like in your head on a scale from 1 to 100, how good do you feel about this answer? And most people who are not trained to do this are pretty bad at producing calibrated probability judgments. This is a skill that you have to learn, and if you're working in forecasting or something, you acquire it, but most people don't have it natively. We can look for model internal representations of confidence in that way, even if they're not actually sort of directly aligned to the probability that the model produces a given answer. Again, like folks working in interpretability here at Harvard think about these kinds of questions a lot. At the same time, I think when you think about what it is that you want to report to a user, we have, like the research community has such a poor understanding of like what model internal notions of confidence look like, that it feels not yet useful to talk about those things as opposed to just training models to put down a number that actually corresponds to the objective probability that this particular answer is going to be right, whether or not that bears any sort of discernible relationship to whatever internal notion of I think this statement is true or I think this statement is false that the model has. But yeah, and then in terms of like literally what is the text that you write down, I do think that just has to depend on your user and your model of the user and your sort of understanding of the degree of mathematical sophistication or whatever that the user has, and maybe the stakes of the application, right? That if it's whatever, you're trying to choose what restaurant to go to dinner and you're trying to figure out whether there's going to be an accessible entrance to the restaurant. The difference between there's a 75% chance and an 80% chance that the restaurant is accessible is not meaningful to you, and you're probably happy with just yes, no, maybe.
Any other questions? Oh.
So something I'm curious about is where you think how we should think about the boundaries between trying to embed world knowledge in the model itself versus sort of focusing on like teaching models to use external tools or external databases of facts, especially when you think about like agent development. There's lots of like, if you ask a math question, it should just write some Python rather than trying to guess the answer itself. And you could imagine the same thing would be true for, facts. Look it up on Wikipedia or whatever.
Yeah.
Curious what you think about that.
Yeah, no, this is a great question. To a first approximation, there are now maybe 3 or 4 different places you can put knowledge in a model, right? Knowledge can reside in the parameters of the model where it's directly accessible. It can reside sort of implicitly in the parameters where you have to do a little bit of reasoning out to remember this particular fact. It's not instantly available to you. Knowledge can reside in the internet, and you can do a web search for it, or knowledge can reside in other kinds of tools that you maybe need to invoke to retrieve things. And and then like one way of answering or one way of asking that question is for a given piece of information, where should it reside? You will occasionally hear people talk about sort of models that are really good at reasoning and don't know how to do anything else at all. That basically says like no knowledge resides at all in the parameters and everything is externalized in the context or in the internet or in the training data or in tool calls or whatever. I think if you like really think about what such a model would look like, it's hard to imagine in the sense that you're having to relearn English from scratch every time you decide what word to generate next, or you're having to go out to the internet and like teach yourself a whole new language over and over again every time you have an interaction with this model. And so some stuff just has to get cached. Some stuff just has to get memorized. And the question of what needs to live where, I think, is ultimately just a sort of question about computational efficiency. But then coming back to these points about sort of consistency, what you want to hope for is that if a piece of information resides in multiple places, it's stored the same way in both of those places. And if it stores or if it's stored in only one place, all of the other places where you might try to look it up say, don't look here, go to the other place instead, right? So what you, almost certainly there are some facts that just have to be in the weights of the model because you don't want to do an internet search every time you want to do the most trivial question answering task. For those things that aren't going to be in the weights, you just need to make sure that there isn't like a stale copy or a wrong copy or whatever. And there's just a pointer that says, I don't know this, do a web search. And again, I think that's something that we could imagine optimizing for, but that we don't do now.
Thank you so much for speaking today. One question I had is, as we trust more in the model's ability to output a reliable confidence interval, but not perfectly, we don't have a perfect level of trust, it increases the propensity for us to be misled or for harms to happen in the world as a result. So it's kind of like, as you approach this asymptote of perfection, there's also a higher risk. How would you think about that or address that concern?
Yeah, well, right. And, I think in some sense saying we want models to hedge in this particular mathematical sense is a proxy for we want the model to say the thing that will cause people to do the right thing in the world. And if we had a way to just optimize for that directly, certainly we would want to do it. I think for the most part we don't right now, and so all we have are these sort of proxy things instead. And I think currently we're so far from. Well, I don't want to say we're so far from people having too much trust in the models, because certainly we're already past the point where people have too much trust in the models. But I think there are sort of cheap things that we can do right now to make a lot of progress on that problem. And hopefully as we get closer to models that are really capable and make mistakes less often, we will be able to figure out what other kinds of guardrails we need or what other kinds of communicative modalities or whatever. This is not a good answer to that question. And I think it's not a question that we've done a good job of solving in analogous domains with other technologies, right? Like self-driving cars get scary. I mean, I guess this is the canonical example, right? Get in some ways scarier and scarier the lower the rate of interruptions is, because the less prepared a person is going to be when the interruption actually needs to happen. And I think ultimately the solution is not to say, is at some point to say, okay, this is as good as it's going to get. Let's stop worrying about reliability and start worrying about changing the rest of the interface that we build around these models so that the whole system is robust to people not being ready to step in or people making the wrong judgments about what's coming out of an LM or whatever.
Maybe one from online.
We have a couple of questions on here about scale. So how do you see model training aligning with the business models or potential business models of some of the big LLM companies? Do they have incentive to optimize for coherence or confidence, or just what are some of the big problems around scaling this?
Yeah, I think with regard to these questions about truthfulness, all the incentives are in the right place. And that at least like causing models when they're in a mode where it's clear you want to give the right answer to this question or say I don't know appropriately is a thing that everybody wants to happen and is good for the bottom line and whatever. That is less clear to me in the case of these questions around personalization, and I think that's something where both with scale, your ability to sort of do modeling of the user that you're interacting with and imagine the kinds of responses that are going to make them happy gets better and better and better, and where actually there's a lot of incentive if you're in the business of selling somebody a monthly plan for one of these models to have that be super well attuned to them and not something that is some competitor can come along and offer a drop-in replacement for right away. And so that I think is something where there will need to be some kind of external framework for thinking about the sorts of personalization that are allowed or not allowed.
Just quick follow-up. It's interesting when you describe that, like, truthfulness in some sense, there is that alignment, because the picture in my head is, to some degree, I wonder if truthfulness may be opposed to engagement. And if there is some misalignment there that may push it back a a little against truthfulness? I don't know.
Yeah.
How do you
Well, yeah, no, I mean, so maybe that was not like the incentive, or there is incentive. Everyone is incentivized to produce a model such that if you can accurately communicate in whatever way, whatever, I'm a serious expert and I only care about true facts according to whatever the objective reality is, blah, 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 blah. That the answers that you get out are right and the model hedges when you don't. Do we have access to that? Do we actually know how to communicate? Even whatever, all of us like clever people sitting here at a university, no, give me like the real facts and not the facts according to the way that I want them. I don't think we have that language to describe to models. And, I don't think we're at a state right now where there is some like whatever deep underlying truth about the nature of reality that GPT-5 knows that it's not telling us because we haven't told it that we're ready for the truth. But, I think all of these subtler, both once you're outside the realm of clear-cut factual questions, subtler factual issues and presentational issues with regard to personalization show up just as much in kind of serious decision-making contexts as they do in people who have their whatever AI girlfriend, boyfriend, or they're using this as their social media feed or whatever. Yeah. So I think maybe another way of saying that is that there's an incentive for the model's internal model of the world to be as good as possible. There is not an incentive for every readout, or maybe even any readout of that internal world model to
reflect that?
Yeah.
Interesting. Maybe. Yes, and just mindful of time. Maybe one more question. Thank you.
Thank you. I wanted to ask about the nature of randomness in these language models. So I think there was something published kind of recently that if you ask ChatGPT and Claude, et cetera, to generate a number, not a random number, but a number between 1 and 50, it always generates 27. And I don't think that's changed recently. But of course, if I ask like a marginally more complex question, there's wild differences, or at least subtle differences, even when I ask the model and between different models. So I guess at a high level, why does that occur, and how does that cohere with your understanding or your argument about uncertainty in these models?
Yeah. So this is maybe a slightly technical answer. If we look back to the first language models, they were used for basically like breaking ciphers during the Second World War. And by design, they were about modeling probability distributions over language and the relative probability of different sentences. And so that sort of random nature is inherent to them, right? A good language model is one that assigns high probability to all of the plausible sentences, or put another way, has the property that when I sample from it, when I generate text from it, I don't know what I'm going to get. I'm going to get anything that's plausible given the context that's come before. That was true for language models used for code breaking. That was true for language models used for speech recognition and machine translation, where we were just trying to do sort of error correction in the outputs. That is very much not the case for language models as we use them today, right? Nobody really cares, I guess I would claim, about the difference between a model that, when I ask it a question at the start of a chat, always produces exactly the same answer, or produces some range of different answers with some probability, because you can always either say, insert some source of randomness into the interaction between the model itself, or say, okay, I want you to flip, I want you to generate not one number between 1 and 100, but a million numbers between 1 and 100, and then I'm going to choose a random item from that list, right? Like if we lived in a deterministic universe and we froze your brain in a particular state, and every time we like wanted to have a conversation with you, we restarted your brain from the same state, and we asked you to generate a random number, you would also generate the same random number every time, and this is fine because we have other ways of sort of getting randomness externally. So I think part of the challenge here is that we have a set of methods for training these models, methods for generating text using these models that sort of conceptualize them as being inherently random objects, but we're rapidly moving towards a world where what people want from them is not randomness in the outputs. And I guess another way of thinking about even thinking about back to these like calibration questions and the first question that was asked here, one way of saying I want the model to express its uncertainty about the answer to this question is for it to have the property that if I ask it the same question 10 times, I get one answer 7 times and the other answer 3 times. Another way of having it express its uncertainty is to say, I'm going to ask it the question 1 time. It had always better output the thing that it thinks is most likely the answer to that question and not any of these others, but then hedge appropriately. And I think we are sort of halfway through the process of transitioning from the first world to the second world.
Great. And speaking of transitioning, apologies to the remaining questions, but if you all wouldn't mind just thanking Jacob for coming. Thank you. And giving talk. Thank you.
Thank you.
Thank you everybody for coming, and please make sure to take your trash with you on the way out and help us